Hello to everybody who's joined the meeting at the minute. Just waiting for a few more to join and to hit the time. Well, hello everyone and welcome. Thank you for joining us today for this webinar on mastering adhesive specifications. I'm Louise Scott, Global Marketing Manager for IPS Adhesives, and I'll be the moderator today. So we're here to better understand specification requirements, reading technical data sheets and using application callouts more effectively. Taylor Santa, who will be speaking today, she is a technical support specialist of IPS Adhesives. She's a skilled practitioner of chemistry and she worked with adhesives for many years. At IPS, she's handling daily inquiries relating to adhesives and substrates. So here's how today will run. We'll start with a presentation from Taylor, followed by a question and answer session at the end. The presentation will run for 25 minutes. And we'll be taking questions throughout. So drop your questions in the question and answers box at the top there. These will be answered at the end, and any that we don't answer today, we'll send out the answers on the email. So just to let you know that this session has been recorded and will be shared with attendees afterwards. So I'll let Taylor take it away.
Thank you, Louise. Like Louise said, my name is Taylor Santa. I have a degree in chemical forensic science from Western Carolina University. I've been working with methyl methacrylate adhesives for about 8 years, mainly with SCIGRIP Adhesives and IPS Adhesives. I started my journey, I guess, into adhesives in the quality control department, working up through performance testing, research and development, and finally at this current role of technical service support. I go out a lot to customers, help them choose adhesives that are right for their application, and then give support throughout their entire process. A little bit about IPS Adhesives. IPS Adhesives is a division of IPS Corporation, a manufacturer of methyl methacrylate adhesives, supplying several different markets such as home building, remodeling, with our seaming adhesives, the marine, transportation, rail, and other markets within our structural adhesive lines. The SCIGRIP brand has offered adhesive offerings that bond together metals, plastics, and composites, as well as cross bonding between all three. We have 2 locations, Durham, North Carolina, and Newcastle in the UK. Both of these are 9001 certified, and we are able to provide adhesives across the globe in all different types of markets. So really, before we want to talk about any sort of specifications within adhesives, we really want to think about the protective equipment and the safety measures needed, and that must be taken when using any type of adhesive. All adhesives are chemicals, and you should protect your eyes and skin from any potential contact with the material by wearing safety glasses and gloves. If contact is made with your skin, please wash with soap and warm water. If contact with the eyes occurs, rinse thoroughly for 15 minutes and seek medical attention. With MMA adhesives, a bit of a chemical spell is to be expected, but it's not dangerous. To lessen the smell, do not dispense adhesives in small, tight areas like a very small, closed room. Please dispense the adhesive in well-ventilated areas, more like a large manufacturing floor. Since these adhesives are all chemicals, there are a few hazard symbols associated with our adhesives. The 4 that you will see in some combination on our labels are the 4 you see down here at the bottom. They represent flammability, health hazard, corrosiveness, and serious health hazard. You wear your PPE and dispense the material in a well-ventilated area away from open flames. You will be very safe using these products. So there are many reasons manufacturers are going to switch to an MMA adhesive in all different markets, whether they're switching from welding, riveting, bolting, or any other type of adhesive bonding that they're using. There's a few common pain points that is seen quite frequently that kind of prompt this switch. Many users have seen long processing times when using other types of adhesives. Some polyurethanes are up to 24-hour cure times before you can move the parts. This not only slows down production, but it also increases the amount of floor space needed to let the parts cure. The process to get these parts together can also sometimes be difficult just purely based on the manner of part joining they are using. Riveting and bolting can be more difficult based on the areas needing bolting or the amount of pre-work needed before joining can even happen, like sanding or just prepping any sort of surface before the join can actually happen. With these rivetings and boltings, the parts will get fairly heavy as you add more and more of this fastening equipment to the part. There's a huge trend for lightweighting across all different types of manufacturers. And so people are looking to replace bolts and rivets. Adhesives are a great choice for that. They're also looking to change substrates. Many customers are moving from metal to metal bonding or riveting to metal and composite or solely composite bonding. Cross bonding of these metals and composites for lightweighting and sleek design parts is a perfect place for an adhesive win. With all of these pain points, adhesives can help alleviate. How do you go about choosing adhesives? What specifications do you need to look for before you even think about an adhesive? And we're going to kind of get into the bulk of that today. Some common specifications you will need to really understand as a customer and know about what really they're looking for and why it's important are time restraints, the types of application the customer wants to use, whether it's mixing by hand using a bulk machine, mixing through a cartridge, how much strength and flexibility the part will actually need to endure, and the amount of vibration in the final part, the gap size that will need to be filled in the part design, how much substrate preparation the customer is willing to do before bonding, the final color of the adhesive, any post-cure work that needs to be performed, such as like sanding, painting, powder coat process, high heat paint bake cycles, anything like that. And then more post-cured adhesive environments that these parts are going to see, such as saltwater environments, high VU exposure, any chemicals that the bonded parts will actually be exposed to. In this next couple of slides, we're going to talk about some definitions that relate to these specifications that really matter to end users. So the first few specifications we're going to talk about are really related to time limits needed when working with adhesives. This is probably the biggest pain point we see across all industries, is that whatever they're doing now just takes a ton of time, and they really want to cut that time down. So the first thing really to consider when choosing an adhesive is how much time it actually does take to get the adhesive laid down the parts together in the proper orientation, and most of the cleanup being complete. This has a few different names throughout the adhesive world. I hear it all the time: open time, working time, gel time. Any of those really mean the same thing. They are the amount of time that the adhesive is still able to be worked before curing begins. For example, a product has a 5-minute working time. The operator will have 5 minutes to get the adhesive laid down, the parts in the correct orientation, and most of the cleanup done on the material before the adhesive really starts to harden and cure. For most of the SCIGRIP product line, we consider this point to be 105 degrees Fahrenheit. As you can see on the graph here below, the pink line, which represents the temperature of a curing adhesive over time, it slowly increases until around 105 degrees Fahrenheit. At this point, the temperature quickly jumps up. At this point, where the temperature increases significantly, where the main part of the reaction is occurring is that very steep incline. The adhesive material is becoming less workable and is beginning to harden. After this 105 temperature is reached, we then have a certain amount of time before we reach the next point, the fixture time. This fixture time is really defined as the time it takes for the main exothermic reaction to be complete. In this graph, you can see where the temperature reaches the highest point, which is called the exotherm temperature, and we'll talk about that more on the next slide. This point, the parts are really bonded together and can start to be moved throughout the process. The adhesive at this fixture time will be around 70% strength. It does take 24 hours for the adhesive to reach full strength, but you can move the parts along the manufacturing process, and they don't really have to sit after the fixture time. So as we talked about in the last slide, exotherm is defined as the peak heat that the reaction releases. For most of the SCIGRIP product line, the exotherm doesn't really reach over 270 degrees Fahrenheit. If used in the correct gap or bead size, the temperature becomes important when bonding together thinner materials of metal and composites, or when you have a large mass of adhesive needed for gap filling. You need to consider manufacturers' recommended gap and bead size when really researching adhesive. Some adhesives are designed to have lower exotherm temperatures in large mass, making them perfect for gap filling. So, for example, our SCIGRIP's SG230 high viscosity series it's created to not boil when applied in large bead sizes up to 2 inches. If you need to fill a gap this size and tried an adhesive not designed for gap filling, you'll see a lot of boiling and bubbles in the large mass of adhesive. This is because the temperature in the large mass is much higher than seen when having a small mass. You know, if you put a bunch of material together, it's going to get hotter quicker and it's going to hold on to that heat and really make the heat skyrocket. This boiling will actually cause weak points and failures in the bond line. A lower exotherm really helps with bond line read-through as well. When an adhesive has higher temperature exotherms and the substrates are fairly thin, you might see some warping of the substrates, and you'll be able to see basically the adhesive line through the substrates. This is not ideal for a finished product, so the manufacturer will have to go and do a lot more post work after the bond, leading to much longer manufacturing times. And the whole idea is to shorten these manufacturing times. The last thing really we want to think about in regards to temperature is the external or environmental temperatures. These environmental temperatures will have an effect on the working time and also the shelf life of product. If adhesive cartridges or bulk material is left in very low temperatures for a long time, the activation chemical found in the activator side, of the material will come out of solution really. It'll almost crystallize, and you'll be able to actually see it's in the activator side. Once this material is out of the solution, it won't go back in, and the adhesive material won't cure properly. You'll see spotty cures, soft cures, essentially ruining any material that you have. On the other side of this, adhesives that are exposed to very high temperatures for an extended period of time will lessen the shelf life of the product. It's basically just speeding up the time you have to work with the material. Some types of adhesives need to be in freezers or heat boxes for best results, but the SCIGRIP MMA line just needs to be stored between 55 and 85 degrees Fahrenheit before use, so you kind of eliminate the need for adhesive freezers or specialty storage containers for adhesives. The last consideration customers need to keep in mind is the temperature of the environment when the application itself is actually happening. So take Southern Florida. Right now in the summer in August, temperatures are 95 plus, right? With this high external temperature, the adhesives will actually cure much faster. In this graph here, you can see as the temperature rises, the reaction happens faster and faster. The opposite happens obviously in cooler temperatures. The reaction time will actually slow down as the temperature drops. Many MMA materials come in different working times, and in order to really combat this, so let's say a boat builder in Southern Florida will switch to a longer working time in the summer months and then a shorter working time in the cooler months to basically have the same working time throughout the entire year. So there are a few different types of strengths that we'll really think about and that customers will really think about when exploring switching from one adhesive to another or from mechanical fastening to adhesive bonding. Tensile strength is one of these. It is the maximum amount of stretching or pulling force a material can handle before it breaks. This strength is tested just as the adhesive material. It's not bonded to anything. So the material using the ASTM method is flattened to a certain thickness and cut out into little things called dog bones, which is what you can see here in the grips on the top photo. And then it is pulled apart. Tensile strain or elongation is often measured and reported at the same time as this tensile strength because you're getting the same, you're measuring both at the same time. This elongation is the amount of extension of an object under stress, usually expressed as a percentage of the original length. So if it starts at 1 inch and it gets to 2 inches, it's 100% growth or stretch. The elongation number really shows how well the matter can withstand like hard hitting vibrations within the part. This product in the graph here will have excellent vibration resistance, while something that only has about a 10% elongation will actually break very fast and will not fare well under a high vibration environment. So another type of strength that is typically looked at is lap shear strength. Before we really talk about the strength, you have to kind of understand what lap shear bonding really looks like. This configuration of bonding, where parts are bonded in an overlap, like seen here in this photo, this configuration expects to see force applied by pulling pieces away from each other instead of pushing towards or bending. The strength of the material here in that pulling mode is called lap shear strength. It is a measure of how much shear force can be exerted on lap joints before failure occurs. It's often tested in during joining process qualifications or material validation to avoid a future failure. Lap shear strength is measured in PSI, pounds per square inch, for the most part. And then the last really type of strength we're going to talk about is fatigue strength. Fatigue strength is defined as the maximum stress a material can withstand for a specified number of cycles without failing. It is a critical mechanical property, quantifies the material's ability to endure cyclic and repeated loading without experiencing fatigue failure. So basically to test this, you bond up these lap shear samples like you see here. They're put into a testing machine and they put a load on the sample. So basically they pull just a certain amount of weight on the sample, and then it pushes and pulls over and over until it reaches whatever cycle time that is set. For all of our cycle times, they are 1 million cycles. If we see a sample go through 1 million cycles of this push and pull without failing, failing really being the bond itself breaking, we know it's going to be able to resist vibrations for the lifetime of any part. So the last couple of specifications we're really going to talk about are gap size and environmental concerns. There are a few aspects of MMA adhesives that need to be kept in mind really when choosing an adhesive for gap filling. First thing to keep in mind is that MMA adhesives are two-part adhesives, like we talked about. It's an exothermic reaction, which means it gives off heat. This heat can be mitigated during the development of adhesives. When choosing an adhesive for large gap filling applications, you really check and make sure that you're that these materials that you're using are designed for those large gap fills, so you're not going to get any boiling, like we said before. The second thing to consider with these gaps is that a lot of times they're going to see a higher rate of vibration. So ensuring that you choose an adhesive that has vibration and fatigue resistance will ensure a stable and lasting bond throughout the lifetime of the product. I know I said last thing. There's one more thing with gap filling. A lot of times when you have gaps in a product, it's going to be on a vertical surface. So having a material that can have a 2-inch bead and not able to, it won't drip down the side of the wall, the vertical wall that you're bonding on, is very, very crucial. The adhesive needs to be able to hold together on a wall without dripping down. So finally, the last specification we're really going to talk about today is what types of conditions the final bonded parts are going to experience after the adhesive is actually cured. So many different MMA adhesives are designed to withstand certain environmental conditions. For example, the SCIGRIP SG800 series was designed to hold its strength when going through high heat processes such as powder coat cycles, high heat paint bake, post bake cycles. The SG100 series includes certain ingredients to ensure bright white colors don't fade when exposed to UV over the lifetime of a part. This is ideal then for exterior bonding of bright white gel coat fiberglass bonding. The SG230 series is used all over the marine manufacturing, both in fresh and salt water. This adhesive has to be tested and will withstand a lifetime of salt spray exposure. So be sure to know what exposures your parts will have after they're actually bonded together in order to have a good lifetime bond. So one thing I think that a lot of people don't realize is the technical data sheets that are with every product line across the industry. There's a lot of information on these sheets. They can be very helpful when trying to find some basic information about the products. Let's look at an example of one of the SCIGRIP MMA TDSs. This is for our product line, the SG5000 series. We've configured our TDSs to have as much information as possible. Most people really only look at that first page here on the left. But if you actually go through and read the second page on the right, has a ton of good information about storage, shelf life, all that kind of stuff. So we're just going to quickly jump into each page and kind of take a closer look at the information related to these applications and these specifications that you can find in these TDSs. So on the first page, we have a lot of information about properties of the products. We can see a quick description of the features and benefits of the adhesive, from a variable working time and different working times to the type of preparation needed for the surface of the substrates. And we'll dive a little bit deeper on the right-hand side of the page. And we'll look into types of substrates that work well with this adhesive, with some notes about how to prep certain adhesives, like the metal is, just removing dust, loose scale, rust, and other surface residue. After we talk about substrates, we jump a little bit into the working and fixture times for the different adhesive and activator combinations. Section also informs customers about the names of cartridges here on the left, as well as the adhesive activator combinations in case somebody is looking to make a switch from cartridges to bulk or bulk to cartridges. Continuing on the first page, kind of jump more into the deeper technical information about mix ratios, density, viscosity, tensile strength, elongation, lap shear strength, and service temperatures. These service temperatures are related to the temperature range the cured adhesive will remain at the same strength at. So basically after the adhesive is cured, this product, well, it goes up to 212 degrees Fahrenheit where it's still the same strength. If it's going through like a powder coat or a paint bake, those temperatures get much, much higher. So this product really wouldn't be a good product for a high heat situation. And we also describe our packaging and availabilities for the product itself. So for this one, we have cartridges in 50 and 490 milliliters, and then we have bulk that comes in 5-gallon pails and then 55-gallon drums. So most of the information on the first page is seen and recognized by everyone who reads any TDS. The second page, like I was saying, people kind of skip it over. There's a ton of information on here that can be gathered. This page describes the types of safety precautions that need to be followed, such as using the material in a well-ventilated area, as well as how to store the materials when not in use. You can see here that it states that this material must be stored in a cool place away from sources of heat and open flames, as well as holding the temperature consistent 65 Fahrenheit to 80 degrees Fahrenheit. And that's just the storage temperatures. We also get information about shelf life here. Here the product has a shelf life 12 months from the date of manufacture if stored correctly in an unopened container. Some other data on the second page, descriptions and graphs of working times in relation to external temperatures. Using the graphs included, we can see that the SG 5000-06 material, when being used at roughly 35 degrees Celsius, we can expect a working time of 5 minutes. And if the temperature was at 13 degrees Celsius for the same product, we'll actually have a 12.5 to 13-minute working time to get the material laid down in parts together. Much of what we talked about today regarding adhesive specification considerations can be found on the SCIGRIP Adhesive technical data sheets for each product. If you do have any questions about any of the specifications or any more information, always reach out to your technical service representative, and they're more than willing to help answer any questions and help you pick an adhesive for your application. So the last thing I kind of want to do, I know we're cutting it close on time, but I just kind of want to go through some actual real life application callouts for different industries just to see why these specifications matter in real parts. So the first one we're going to look at is big trucks. Here at the bottom, we can see the heading for headlight surrounds. There's a good chance that this area will actually see some higher than average temperatures to ensure we don't lose any strength as these temperatures go up. You want to make sure you use a high heat product like the SG 800 series, help the longevity of the bond. You look at the cabin and dashboard bonding, we tend to see materials and plastics used that are hard to bond to our low surface energy plastics. So to bond these materials, we really want to use an adhesive designed for difficult bonding like the SG 400 low surface energy product. Next, we'll look at some wind bonding. Again, starting at the bottom with field repairs. Repair adhesives are often needed to fill large gaps in substrates after damage from lightning strikes or shipping damage. Using a product like the SG 350L can ensure that there is no boiling at gaps up to 6 inches and a quick working and fixture time to repair these blades quickly and get it back into service. Bonding around the roto hubs requires an adhesive that can bond both composite and cast iron. These parts see a ton of vibration, and they'll require an adhesive with a high fatigue or vibration resistance. Then finally, we'll look at just some marine applications. When mounting hardware on the deck of a boat, there's a good chance that the adhesive is going to be exposed to UV. UV will yellow certain adhesives, so ensuring to select an adhesive with UV inhibitors, as well as a bright white color to match most of the gel coat seen on these decks, is very important. When looking at bonding the deck hatches, there's a high likelihood that this bond is going to get sprayed with salt water a ton throughout its lifetime. So being able to withstand this saltwater spray is very important against the longevity of the bond. The last part we're really going to look at today is bonding stringers to hulls and hulls to decks. These parts of the boat really take the most beating over the lifetime. There's a lot of vibration that goes through these parts, so high fatigue results and vibration resistance characteristics are key. The parts of the boats that are often where a majority of the large gaps are found are also in the stringer to hull and hull to deck. Having these adhesives that can withstand high vibrations and can fill these large gaps without boiling or sagging is crucial. So adhesives in the SCIGRIP series like the SG 230 series and the SG 2000 are really designed for this application. I in no way whenever every type of bonding and every type of industry that is listed on all of these callouts. But if you do want to take a closer look at any of the application callouts, you can find all the callouts and all the technical data sheets, other webinars, and any other information on our website at SCIGRIPadhesives.com. Right. Anybody have any questions?
Well, it doesn't look like there's any questions yet in the chat. We've all had a chance to put questions in throughout the presentation. So as we're running short of time, what you can do is you can contact us on the SCIGRIP website and put a question in there and we'll get back to you. I think this is all we've got time for today, and just it concludes our mastering adhesive specifications. And thank you to Taylor Santa for the insights you've shared, and I'm sure you'll all agree it's been a valuable discussion. Of course, thanks to all to you for attending and for joining us today. We really appreciate your time and participation. If you like the recording, we will be sending that out straight afterwards, and other relevant resources. Be sure to follow us on LinkedIn or check out our SCIGRIP website resources page for more content like this. Thanks again, and hope to see you all next time, and take care.
Thank you all.